Christian, thank you a lot for presentation, for introduction, and hello everybody. I'm going to my name is Ivan Kozyatnyk. I am present in Linköping University and University Hospital, and my presentation is about application of biochars for water treatment. And topic is water treatment using biochars and Moringa olifeira seeds for water treatment. So let's start to talk from the beginning about water problem in developing countries. In developing countries, there is a huge infrastructure deficit in sewage system due to perceived unaffordable investment cost, despite the benefits of improved sanitation management for the population health. Due to urbanization, industrialization, and population growth, the demand of water is obvious. As you all may know, this is a huge problem in many developing countries. And now, several important questions. Will the available water resources meet the ever-growing needs in a sustainable way? Where do we find the extra water needs to sustain human activities? And I would say it's a great problem. And for developing countries, it's how do we reduce women's water burden, because basically all these problems lay on their shoulders. They need to carry this water for a long distance, and quite often this water is not of proper quality. So there are plenty of such questions in these countries. But low-cost reuse of gray water maybe is one of the possible solutions for these problems. What is gray water? Gray water is water from bath, sinks, laundry, and it accounts about 60% outflow from homes. Basically, it's all outflow from homes except fecal outflows. This gray water contains little pathogens and 90% less nitrogen than toilet water, and therefore requires a different treatment process than toilet water. This gray water often pollutes drinking water source that people are forced to use due to water shortage in developing countries. Therefore, it's a challenge to develop technology for the treatment of water of this kind. But what can be a solution of this? And we need to understand that in developing countries, we need to base this technology on locally available resources and methods. So local cheap crops such as oil palm and coconut shells, sugarcane bagasse, and firewood has attracted much attention as an alternative method for producing carbonaceous materials such as biochar that are suitable for treatment of gray water and contaminated drinking water. However, biochar, in comparison, for example, with activated carbon, has a limited ability to selectively absorb pollutants at high concentration due to the low porosity of biochars. And one of the way to improve the performance of biochar in environmental remediation is various modification methods, including activation, surface oxidation, impregnation of metal oxides, and functionalization. However, most of these methods require complicated equipment and reagents that are not available in developing countries, basically on place where these biochars are produced. For instance, in the kind of cooking stove that you see on this figure. And one of the possible way to improve water treatment schemes with biochars is to combine them with other methods. It can be, for instance, coagulation or flocculation. And one of the source for this method is tropical tree Moringa olifeira. It's small tree that is native to many parts of Asia, Africa, South America, and Pacific and Caribbean islands, basically for global South. The active component of I would like to tell a bit more about this tree. It's also known in some parts as miracle tree because basically almost all part of this tree are used for that or that activity. For instance, it's possible to do tea from leaves, extract oil from seeds, and it has application in medicine, so on. But we are focused on seeds, and the active protein component in the dried crushed seeds of Moringa olifeira is a soluble proteins that has antimicrobial and flocculating properties. It's possible to coagulate, to use it as flocculant or coagulant. However, some Moringa seed proteins may remain in water after treatment. And these affect smell, color, and taste, and the microbiological stability of water, making it undesirable. So the main goal of this project was to develop the low-cost method for grey water treatment from organic pollutants and heavy metals, combine biochars and Moringa water extract to develop biochar sorbents based on locally available crops and wood residues, and combine them with Moringa in one water treatment process. Also, we wanted to assess effectiveness of this process and to determine the environmental impact, but it's further plans. So let's talk a bit about biochar that we use in this work. It was biochar sample produced from wood biomass from eucalyptus and macadamia in a small gasifier cooking stove. And it was taken at a farm in the Siaya district in Western Kenya. So for this work, we used powder fraction of biochar with size less than 0.15 millimeters. And we did characterization of properties of these biochar by BET, FTIR, determine point of zero chars, and surface functionality with X-ray photoelectron spectroscopy. What I would say about this sample of biochar, it was quite high carbonized material. Temperature of carbonization, it was measured by my colleagues in Kenya. It was about 700 degrees, so it was quite well carbonized. It has relatively high porosity as for biochars, about 50 square meter per gram, and also has some oxygen functionality on its surface. But let's proceed to the water treatment part of this work. At the very beginning, we wanted to understand how do we need to apply Moringa water extract and biochar in which order. So we wanted to test how they removed a set of heavy metals, chromium, cobalt, nickel, copper, zinc, arsenicum, and lead, and see a set of organic contaminants: caffeine, trimethoprim, chloramphenicol, diclofenac, carbamazepine, and bisphenol A. So this set of metals represents both cations and anions, and organic compounds were chosen in order of their coefficient of distribution, basically based on their hydrophilicity, hydrophobicity, which is quite important for water treatment processes. So, but let's return to the order how to use, what to use first, what to add first to the water, biochar or Moringa. So it's seen that for heavy metals, there was no such a big difference how to apply them, but for organic pollutants, it seems that it's better to add biochar first to steer solution, and only after that, in about 1 or 2 hours, add Moringa extract to coagulate all this slurry. And the next step was to choose dosage of biochars and Moringa. So for biochars, it's seen that the higher dosage, the better it is, the better it removes both metals and organic pollutants. And it's also seen, and it's quite interesting, that anion metals, chromium and arsenic, were not removed in these water treatment processes, probably because of repulsion between these negatively charged anions and surface groups of biochars. For Moringa dosage, it was not that clear. It seems like the highest dosage was not the most preferable, that we can go for the lower dose of Moringa extract and to combine them together with biochar. But the main goal was to see how it works with gray water. Therefore, we included the necessary components in the simulated gray water, such as humic acids, clay, kaolin, and surfactants. We tested how biochars and Moringa would perform in the presence of these individual components, and simulated gray water by mixing all these components. And it was observed that coagulation did not occur when the Moringa extract was added to the water where humic acid were. Basically, we did not observe coagulation in this case. So we may say that humic acids inhibits removal of color, turbidity, heavy metals, and most likely of complexation mechanism. Kaolin almost does not prevent the removal of heavy metals, but inhibits the removal of organic contaminants, and surfactants inhibit the removal of both heavy metals and organic pollutants. And the main problem was humic substances, and therefore we decided to test if increasing of Moringa dosage will increase efficiency of the process, and we tested in 5 times higher dosage of Moringa extract, and basically it worked. It was visually evident that coagulation was taking place in this case. removal efficiency increases the both heavy metals and organic pollutants. Increasing the dosage of Moringa allows to remove chromium and arsenic, and it's quite important because they were not removed previously. And it was most likely due to the successful removal of the complexes with humic acids. It's also seen that we did not achieve reduction of in pH in our experiments, it indicating that treated water had a slightly alkaline pH around 8, caused probably by residual surfactants. And the residual concentration of total organic carbon was most likely because of residual Moringa proteins. But all that was lab experiments, and real life is real life. So next step of the project was to test this combination of biochar and Moringa in real life scenario. And we did that this year in Kenya in June and July in 3 weeks field trip. It was in 2 counties in Kenya, in Kwale and in Siaya, 5 households in each county. We tested 2 methods for grey water treatment. At the beginning, we asked women in these small farmer households to wash clothes as they usually do. And then we tried to treat this water in filters consisted with locally available sand and locally produced biochar. And in batch method, when we add Moringa extract to the gray water, stir it for some times, and after that add powder biochar. Basically, both these methods were effective for removing turbidity and color from this water, but they were very, very dependent on several parameters, such as how much water was used for washing clothes, on the quality of the water used, on the amount of washing powder, and also quality of sand for filtration influenced quite a lot on the final quality of the water, because if the sand contain some kind of soil residue, it may give secondary color to the treated water. So we also developed quite a simple recipe to prepare Moringa extract using available on each kitchen products. It's table salt and water. And we also adapted this recipe not to chemical terms like 1-2 molar solution of sodium chloride, but half spoon of table salt and amount of water, and so on, so on. So it was about, basically it was really exciting field work, and we got a lot of question and responsible from the farmers. A lot of expected and unexpected question. The main one was, okay, it's possible to remove color and turbidity from this water, but if you think that it's possible to drink this water, so the question, the answer is quite direct, no. And after that appears a very important educational issue that we need to educate. If we proceed with this work, we need to educate people that this water can be reused only for gardening and not for drinking or for reusing in washing. So in total, we trained 31 participants. In qual, it was 11 women and 5 men, and in CI, it was 8 women and 7 men. So, some conclusion. This work aims to create low-cost strategies to remove organic pollutants and heavy metals, as well as color and turbidity in developing countries using biochar from locally available source and active ingredients of Moringa olifeira seeds. So, look like it's possible to reduce the content of heavy metals and organic pollutants, as well as reduce turbidity and color of the great water, even in the presence of humic acid, clay, and surfactants. Both methods, batch and filtration, tested during field work, allowed to get water available for using for household needs, for washing and gardening. But we need the results of all tests to evaluate water quality after treatment. And efficiency of water treatment depends on many factors: concentration and type of surfactants, type of pollution in great water, quality of water in the area, and quality of sand for filtration. And reusing grey water for household needs will allow women farmers, especially older and expectant, to carry less water from wells over a long distance. So at the end, I want to thank my collaborators, Dr. Mary Jenga from World Agroforestry Center in Nairobi, Kenya, for Dr. Cecilia Sundberg from Swedish Agriculture University, two master students, Ketin and Dennis from Nairobi University, all hospitable farmers that allowed us to do our experiment in their homes, and to Swedish Research Council for Sustainable Development Forums for finance for this project. So, your questions?